something like this. So this would be the graph of 4 minus x. It is this one. So this is the graph of 4 to the power negative x. Also, you can say to yourself that 4 to the power negative x is in fact 1 over 4 to the power x. So it's an exponential function with base less than 1. So the graph would be decreasing like this. Okay, now what about this function, h of x? It has the same graph as g of x. So this one and this one are similar, the same, but this minus sign changes what? It reflects the graph of g about the x-axis. So if you reflect the graph, this graph in one about the x-axis, you will have this graph, isn't it? If you graph it about the x-axis, you have number 2. So this is negative 4 to the power negative x about the x-axis. Now what about r of x? You take this graph 3 units up. You raise plus 3 means this graph, which is the graph of h, this one and 2, you raise it 3 units up. If you take it 3 units up, now here the horizontal asymptote is y equals 0. That's the horizontal asymptote. If you take it 3 units up, it would be y equals to 3, this one. So this function has the same graph like this, but shifted 3 units up. So this is the graph of negative 4 to the power negative x plus 3. So these are the 4 questions. Now here, graph f and g in the same rectangular coordinate system. Use transformations of the graph of f to obtain the graph of g. First, let us graph f of x and f of x, which is 2 to the power x. We know the graph of this function, so we choose as usual 3 points, negative 1, 0, 1. 2 to the power negative 1 is half, 2 to the power 0 is 1, 2 to the power 1 is 2. And now I can sketch the graph of f of x. I know it's a graph, it's an increasing function. At negative 1, it is half. At 0, it is 1. And at 1, it is 2. So that's the graph of f of x. Now, in the same rectangular coordinate system, graph g of x, minus 1. There is only minus 1 here. What does it change, this minus 1? We take the graph of f 1 unit to the right. 1 unit to the right. If you take it 1 unit to the right, you can take it 1 unit to the right. Take this point here, take this point here, take this point here, and sketch the graph. Okay, so you can sketch the graph of this function easily, also like this. This would be the graph of g of x. Or if you want, you can in fact add to each x 1 because you are taking the graph to the right. So the table of g of x would be the y without any change, half 1, 2. But the x, we added 1 to each x. So we have 0, 1, and 2. So at 0, it is half, this point. At 1, it is 1, this point. And at 2, it is 2, this point. So that's the graph of f of x and g of x at the same rectangular coordinate system. Write each equation in its equivalent exponential form. To change the logarithmic to exponential form, we just say f and only f. And now 49, this 49 raised to the power half is equal to the number 7. So this is how to change logarithmic to exponential. Here, write each equation in its equivalent logarithmic. Now I have exponential, how to change it to logarithmic? Well, for the power, I take it alone in one side, and I write log. B is the base, I put it here also a base, and 625 will be inside the log. Evaluate each expression without using a calculator. I can evaluate this in 2 ways. I can write it ln 1 over e square is e to the power negative 2, and ln cancels e, so the answer is -2. Or you can say this is ln 1 minus ln e square using the properties of logarithms, and ln 1 is 0, and ln e square, ln and e cancel each other, and you have -2, 0 minus 2, so the answer is -2. How to evaluate this? Log 8 is 1, log b is 1, so we have log 1 3, and log 1 to any base is just 0, so this is the answer. Begin by graphing log x to the base 2, then use transformations of this graph to graph the given function, this function. Now, what is the difference between this function and this function? Only the -1. The -1 will take the graph of log x to the base 2 1 unit down. So let us start by graphing f of x. Did he ask here a graph and give equations of asymptotes? Okay, we did not give equations of asymptotes. Equations of asymptotes, the asymptote here, y equals 0. This is the horizontal, this is horizontal asymptotes. Use the graphs to determine the function's domain and range. Okay, so domain of f is equal to the domain of g, set of all real numbers, any exponential function, domain or real numbers. And the range of f is also equal to the range of g from 0 to infinity. The range is clear from 0 to infinity, and this line is a horizontal asymptote, which is y equals to 0. So you need to read the question carefully and answer everything in the question. Here, he says, begin by graphing f of x. So let us graph f of x. Again, I will make a table for f of x, and this is the logarithmic function. So we agreed to take values like this. Base is 2, the base is 2, so I write x2 and 1 over 2 and 1. So f of half, log half to the base 2 would be -1. -1. And log 1 to the base 2 is 0. And log 2 to the base 2 is 1. So instead of having -101 here with the x, I will have it with the y, because log x to the base 2 is just the inverse function of the exponential function. And now I can sketch the graph. I know the graph of this function because this is logarithmic. Base is greater than 1, so the graph is increasing like this. But let us do it. This is x is half, y is -1, so it's this point, and 1, 0, and 2, and 1. And the graph would be like this. So this is the graph of this function. Of course, there is a vertical asymptote. This line is a vertical asymptote, and the equation is x equals to 0. This is the vertical asymptote. What is required in the question? Use transformations to graph the h of x. What is the graph's x-intercept? I need the x-intercept. What is the vertical asymptote? Use the graphs to determine each function's domain and range. Okay. Now let us sketch the graph of h of x. So let me make a table for h of x. What happened? 1 unit down. So you can take the graph 1 unit down. In fact, you can do it easily like this. This one bring it here, this bring it here, 1 unit down, and this one bring it here, and you can sketch the graph of the function h of x. So this is h of x and this is f of x. Okay, they have the same vertical asymptotes. They have the same vertical asymptotes. Also, you can write the table. What happened 1 unit down? When you take the graph 1 unit down, you subtract 1 unit from y. So x does not change. And -1 would be -2, 0 minus 1 is -1, 1 minus 1 is 0. So now if you check the points, you have half and -2. So this is half and -2. This is this point. and 1 and minus 1, this is this point, and 2 and 0 this point, and like this. Now what about the x-intercepts? Here for f of x, x-intercept is 1, while for h of x, x-intercept is 2. This is 1 and this is 2. The domain of f is equal to the domain of h is from 0 to infinity, positive real numbers, and the range of f is equal to the range of h, or real numbers, from negative infinity to infinity. As you can see, the graph is everywhere on the y-axis. Did he ask here about the y-intercept graph and give? No, he did not. Okay, the y-intercept here is 1, here is half, if he asked about. All right. Graph F and G in the same rectangular coordinate system. Use transformations of the graph of F to obtain the graph of G. Graph and give the equations of all asymptotes. Use the graph to determine domain and range. All right. Let us start by graphing f of x, log x. To the base what? What is the base? It is not written, so it is 10. So to graph x and f of x, we said if the base is 10, I take 1 over 10, 1, and 10. Always you take these three numbers. If the base is 2, half, 1, and 2. 3, 1 over 3, 1, and 3. Why? Because log 1 over 10 to the base 10 would be negative 1. And log 1 to any base is 0. And log 10, 10 to the base 10 would be 1. So you will have negative 1, 0, 1. And you can sketch the graph of this function same like the other one. So, but here, let me, okay, if this is 1, so negative 1, 1.10 would be very small number here. So if this is negative 1, it would be here, and 1 and 0, this is the x-intercept, and 10 and 1, it would be somewhere here, for example. So the graph would be like this. Okay, this is the graph of the function f of x. Okay, now what happened here? This 3 will take the graph 3 units to the left, and this minus will be symmetric or reflection about x-axis. Okay, so you can take the graph, this graph 3 units to the left, and then make a reflection about the x-axis. Or you can find the table. Okay, you can find the table of the new function. If you take the graph 3 units to the left, and you should start by the horizontal transfer, the horizontal shift. If you take it 3 units to the left, you subtract 3 from each x. Okay, so you will have this. This is now the graph of log x plus 3 only, without the minus. I subtract minus 3, so 0.1 minus 3, it would be negative 2.9. 1 minus 3 is negative 2. 10 minus 3 is 7. Okay. And here the y does not change. Then when you reflect the graph about the x-axis, you multiply each y by negative y. So in fact, I can do this in one step. I can find the table in one step. So this is g of x. I multiply each y by minus. So this would be plus, and this would be minus. So negative 2.9, this is 1, this is, if we go, this is 2, this is 2.9. So this is negative 1, negative 2, this is negative 2.9 with plus 1 here, okay, and negative 2 with 0, and 7 with negative 1. Can you imagine the graph? Okay, let us see what happened. Where is the asymptote? Where is the asymptote? Well, the vertical asymptote for the function f of x is this one, x equals to 0. This is vertical asymptote for f of x. Okay, when you shifted the graph 3 units to the left, where is the x, the new vertical asymptote? This is the new vertical asymptote. This is the line x equals -3. This is the vertical asymptote of g of x. Okay, so this is the vertical asymptote. Now you shifted the graph 3 units to the left, so it's like this, but you switched, you reflected the graph about the x-axis. So it will go up and then pass by this point and then go like this. So this is the graph of g of x. Now what is the domain? Now for the function f of x, domain f of x, look to f of x, the domain is from 0 to infinity, and the range is from -infinity to infinity. But for the function g of x, the domain is not from 0 to infinity. It's from -3 to infinity because we shifted the graph 3 units to the left. So the domain is from -3 to infinity, but the range is always for the logarithmic function, it's from -infinity to infinity. So that's the answer of this question. Find the domain of the logarithmic function. Well, the domain of the logarithmic function, anything inside the logarithmic function should be positive. So x minus 1 square, which is inside the len, should be positive, greater than 0. But we know that x minus 1 to the power 2 is always positive or 0 because there is a square here. So this is always positive, or it could be 0. We need it to be positive. It's always positive. We don't accept that it could be 0. So the only value which is not in the domain, the value that will make x minus 1 square 0. And x minus 1 to the power 2 would be 0 if x is 1. So x cannot be 1. So the domain of f of x would be all real numbers except 1. You can write this if you like from -infinity to 1, union from 1 to infinity. Students in a psychology class took a final examination as part of an experiment to see how much of the course content they remembered over time. They took equivalent forms of the exam in monthly intervals thereafter. The average score f of t. So that's the first important sentence for me. What is f of t? F of t is the average score for the group after t months. What is t in the equation? Number of months is modeled by this function. So this function has two variables, t and f of t. What is t? Number of months. What is f of t? Average score, where t is between 0 and 12. So those only from 0 to 12. What was the average score when the exam was first given? When the exam was first given, what was t? See here, after t months. But when the exam was first given, t was 0. The time was 0. So in that case, the average score, which is f of t, would be equal to 76 minus 18 log 0 plus 1. You put t0. But log 1 is 0 times 18, 0. So the answer is 76. So the average score when the exam was first given is 76. Average score is 76. That the average when the exam was first given, okay? Before any time passing. What was the average score after 2 months? All right. After 2 months, 2 months of the exam, what was the average score? You replace t by what? By 2. You find f of 2. You replace t by 2 and you find f of 2. So here this is f of 0 and now you find f of 2. So f of 2, you just replace t by 2. Let me do it by calculator. It is 76 minus 18 log to the base 10, okay, times log 3, because 2 plus 1 is 3. Well, the answer is 67.4. What about f of 4 months? You add another 2, okay, and the answer is 63.4. 6 months, you replace t by 6, 60.8. 8 months, you replace t by 8, 58.8. You notice that the average is decreasing. If 1 year means 12 months, because t is evaluated in months. So if you replace t by 12, you will have 55.9. All right. So these are the average scores after 2, 4, 6, 8, and 12 months. Use the results from parts A and B to graph f. Okay. If we want to graph the function f, of course, the function f is a logarithmic function. The base is 10, so it should be increasing. But this minus sign will will reflect the graph about the x-axis, so it would be like this, and it would be decreasing. So 76, when t is 0, this is t, and this is f of t. Let us say that this is 80, and this is 40, and this is 60, and this is 20. So 76 for 0, so it is about here for 0 when t is 0. Now let us take this is 1, 2, 4, 6, 8, 10, and 12. So when t is 2, 67.4, somewhere here, okay. When t is 4, 63.4. When t is 6, 60.8. And when t is 8, 58.8. And when t is 12, 55.9. If you complete the graph, this is the graph of this function. It is decreasing. So describe what the shape of the graph indicates in terms of material retained by the students. Decreasing. Material or retaining is decreasing over time. So when the time passes, the retaining of the students decreases. Okay, use properties of logarithms to expand. To expand, we write it log square root of x. We change division into subtraction. And the answer would be, now this is x to the power half. You can take half outside. So it would be log x to the base 4 minus 4 to what power equals 64? I think 4 to the power 3 is just 64. So log 64, 4 is 3, and that's the answer. Expand. You first write it ln x over e to the power 1 over 3, because this is the third root, and you take 1 over 3 out, and then you have x over e. You use the property to write that ln x minus len e. So the answer would be 1 over 3 len x, and len e is 1. 1 times 1 over 3, so that's the answer. Use properties of logarithms uh, to condense, to write it as a single logarithm, we have to take this half up. So we have len x to the power half minus len y, and subtraction, we change it to division. So it would be len square root of x over y. Solve each exponential equation. These are exponential equations. Uh, you can write each base here as 5 to some power. 125 is 5 to the power 3, and 25 is 5 to the power 2. If you find 5 to the power 3 by the calculator, you will get 125. So now if you use the properties of exponents, 3 times x you multiply equals 5 to the power 2. Now the base is equal, so the powers are equal, and x is 2 over 3. To solve this one, I have to divide first by 9, because I cannot apply len unless I have e alone isolated in one side. So I start by dividing both sides by 9. 1269 over 9 is 141. Now I can apply len to both sides. And we know that len with e cancel each other, and we have 5x equals len 41, or the answer is len 141 over 5. What did he say? Where necessary, express the solution in terms of natural logarithm. Use calculator to obtain a decimal approximation correct to 2 decimal places. So I can find len 141 divided by 5 and approximate this to 2 decimal places. So I will have 0.989, so I will make it 9. So the answer is 0.99. How to solve this? I apply immediately len to both sides, because I cannot write 375,005 to some power. So len 5 to the power 4x plus 2 equals len 37500. Now 4x plus 2 will come in front of len 5, and I have here len 37500. If you want, you can divide now both sides by len 5, okay? And then you can add 2 to the other, or to both sides, -2, subtract 2 from both sides, and then you can divide both sides by 4 to get 4. So the answer is -2 over 4, which is negative half, plus len 37500 over 4 times len 5. And you can use the calculator, -0.5 plus len 37500 over 4 times len 5, and approximate your answer to 2 decimal places. So it's 1135, so it would be 4. So the answer is 1.14. How to solve this equation? We can immediately factor this equation. We have e to the power 2x, we can write it e to the power x times e to the power x. If you multiply these two, you get e to the power 2x. And -6, we can write it -3 plus 2, because the product is -6, and when you add, you get -1. So now 2 times e to the power x minus 3 e to the power x, you will have negative e to the power x. So I have two solutions. Either e to the power x is -2, and this solution is rejected or impossible, because the exponential function cannot be negative. So this answer is not accepted, rejected. But, or Ex equals 3, that's a possible answer. To solve for x, I apply len to both sides. Len cancels e, and the only solution would be x equals len 3. So that's the answer of this equation. Now, how to solve logarithmic equations? I have to isolate len in one side, so I have to take 3 to the other side. So I will have 4 len 2x equals 15 minus 3, that's 12. Now I have to divide by 4 to isolate the len. 12 over 4 is 3, and now I can change it to the exponential form if I like, if I want, if I know that the base is e. So 2x would be equal to e to the base to the power 3. Or you can raise both sides to the base e. E cancels len, and you will also get to x equals e to the power 3, or x is e to the power 3 over 2, or half e to the power 3. That's the answer. The last, before the last question, this one, I have two logs. So I have to make them one logarithm. How? I change the negative into division. So I will have log x minus 1 over x plus 2 to the base 3 equals to 2. And now I change this to the exponential form. So I will have x minus 1 over x plus 2 equals 3 to the power 2. And 3 to the power 2 is 9. Now cross multiplication, I will have x minus 1 equals 9x plus 18. And now if you take 9x to the other side, x minus 9x is negative 8x, and bring 1 here, 18 plus 1 is 19. So x would be 19 over negative 8, means x is negative. Now log negative 19 over 8 minus 1, if you replace x by this number, this is not defined. This is not defined. So this answer is rejected. So the solution set of this equation is phi. It has no solution. The last question, I believe, yeah, the last question before the rules. Similar to the previous one, I will leave this side as it is, and I will change now this side to using the product rule, x minus 3 times x plus 5. Let us find the product. We have x squared minus 3x plus 5x is plus 2x, and negative 3 times 5 is negative 15. You have log in both sides, so you can write x squared plus 2x minus 15 equals 2x plus 1, and you solve this equation. So here you have 2x, and here you have 2x. They cancel with each other. And if you take negative 15 to the other side, 15 plus 1 is 16. So in fact, x is positive or negative 4. Well, negative 4 is rejected. It is not accepted because if you put log, for example, log negative 4 minus 3, if you replace x here by negative 4, this is not defined. So negative 4 is not good. What about 4? Let us check that 4 is correct. So we have log 8 plus 1, 9 to the base 4. Is this equal to log 4 minus 3, 1 to the base 4, plus log 4 plus 5 is 9 to the base 4. We know that log 1 is 0. Log 9, 4 equals log 9, 4. That's correct. So the solution set of this equation is 4. Thank you very much. I hope that you benefit from this review. I stop here, and please ask any question.